I remember the moment this question first stopped me cold. If every conscious being vanished tomorrow, would time keep moving? Would the universe still have a past and future if no one were there to remember or anticipate anything at all? At first, the answer feels obvious. Of course, time would continue. Stars would still burn. Galaxies would still drift. Atoms would still vibrate. But when we look deeper, through physics, neuroscience, and philosophy, the answer becomes far more subtle and far more fascinating, because it turns out that whether time exists without observers depends entirely on what we mean by time itself. Two very different meanings of time. One of the most important insights is that time exists in two distinct forms. Physical. Time refers to the ordering of events in the universe, the sequence of changes that can be measured by clocks. Experienced time refers to the human perception of duration, memory, and the feeling that moments flow from past to future. Observers are clearly necessary for experienced time. Without consciousness, there can be no perception of duration, no awareness of past or future, and no sense of a present moment. The deeper question is whether physical time itself requires observers. The classical view: time exists independently in classical physics. The answer seemed straightforward. Isaac Newton described time as absolute, a universal flow that exists independently of anything that observes it. In this view, time would exist even in an empty universe. Events would still occur in sequence. Change would still unfold. Observers would simply measure time, not create it. Einstein's revolution: time without a universal clock. Einstein transformed this understanding by showing that time is not universal. Time depends on motion, gravity, and perspective. Different observers can measure different durations between the same events, yet relativity still treats time as an objective feature of spacetime. Even without observers, spacetime geometry would still exist, physical. Processes would still occur, clocks would still measure durations if they were present. Relativity therefore supports the idea that physical time does not require observers. Quantum mechanics complicates the picture. Quantum physics introduces a deeper mystery. In quantum theory, measurement plays a crucial role in determining physical outcomes. Some interpretations suggest systems remain in multiple possible states until observed. This raises a provocative question. Could time itself depend on observation? Most physicists believe the answer is no, but quantum theory does reveal something profound. Information and interaction play central roles in establishing reality, and this leads to a very different way of thinking about time. Time as an emergent property. Modern research increasingly suggests that time may not be fundamental. Instead, it may emerge from deeper processes such as information exchange, entropy, increased quantum entanglement, irreversible interactions. In this view, time arises whenever systems record differences between states. Observers are not required for this process. Physical interactions themselves create informational records that establish temporal order. Time, therefore, may emerge from change itself, not from awareness of change, where observers become essential. Observers become crucial when we consider the direction of time, the arrow of time. The distinction between past and future is closely tied to memory and information storage. Without systems capable of remembering past states, there would be no subjective sense of temporal flow. The universe might still change, but it would not be experienced as time passing. In other words, physical time may exist without observers. Experienced time cannot. Imagining a universe. Without observers, imagine a universe containing matter and energy, but no conscious being. Stars would still form and collapse. Galaxies would still evolve. Entropy would still increase. Physical processes would continue in ordered sequence, but there would be no awareness of past or future. No perception of duration, no sense of now. Time would exist as structure, but not as experience. The radical possibility, a timeless foundation. Some theories of quantum gravity suggest an even deeper possibility. At the most fundamental level, the universe may be timeless. Time could emerge only when parts of the system interact and record information. In this scenario, observers do not create time. but they help define its meaningful structure. Without observers, reality might exist as a vast configuration of states without any perceived flow. Connection to humans, actuators of time. This perspective aligns directly with the central idea explored in Humans, Actuators of Time. Humans do not create physical time, but through memory, perception, and narrative, we transform physical change into lived time. We record events, we interpret sequences, we construct continuity. In doing so, we generate the meaningful experience of temporal reality. We are not merely observers of time, we are its interpreters and organizers. Conclusion: could time exist without observers? The best scientific evidence suggests a nuanced answer. Physical time, the ordering of events and processes, likely exists independently of awareness. But experiential time, the sense of flow, duration, and direction, requires consciousness. This reveals a profound truth. Time may be both an objective feature of the universe and a subjective creation of awareness. The universe provides change. Observers provide meaning. And in the meeting between change and awareness, time as we know it comes fully alive.